Hey, did you know that you can optimize size in two-dimensional geometry using quadratic functions? I'm going to show you how to do it in this video in simple way. Welcome to another video. My name is Bogdan Marzewski. We make algebra easy just for you. So let's dive in to this word problem. So the best rectangle, maximizing area with a fixed perimeter. So rectangle would be the main point of interest. So that's the geometry shape that we have to sort of recall how that looks like, what are the features of that shape, etc. How to find the area, how to find the perimeter is already something that you expected to know. If you don't know, don't worry about it. You can always quickly search it up and find what is the area formula, what is the perimeter formula. So the question itself, put in the context of building something in that rectangular shape. A farmer wants to build a rectangular pen for animals. So using 40 perimeter meters of fencing. So that is giving you sort of the information about that. The area is of that rectangular shape and the fencing around would be connected to the perimeter. So this is how you observe patterns in mathematics. So, and it says he will fence 4 sides of the rectangle and wants to use all of that fencing material. So the fixed perimeter is right here. And the challenge here is, what is the dimension? So length and width of that rectangle so that the enclosed area is as large as possible. So you're optimizing or you're making the biggest possible area by tweaking with what you have for the fencing perimeter, tweaking the dimensions. Now, diagrams most of the times are not provided necessarily when working with word problems, but you have to bring it from your imagination on paper, a picture of sorts, so that there is a better connection. You start developing a better plan once you have a diagram in front of you. So I just created quickly this diagram where I labeled L and W as the sides of the rectangular shape. The perimeter formula is recalled. So this is the total distance around. So you're going to add L and L plus W, another W. So hence you have 2L plus W. So that makes sense. And the area is the product of length times width. So when you have an area, you multiply 2 variables. So that's sort of the connection with quadratics. This is a linear function. You have a sum of 2 variables. So the degree here is 1. When you're multiplying 2 variables, the degree is 2. So this is how quadratics are being utilized in this word problem. So let's identify the objectives, define the variables, right? So when you planning a solution, you have to create a diagram. Pick letters of your choice to identify them as your variables. Use the perimeter information, so you have to make sure that you have that right in front of you. Since the equation of the perimeter involves 2 variables, you will be changing the area formula from 2 into 1. So you have to know how to exchange or rearrange that perimeter equation so that you can get 1 variable in terms of the second one. Build the area function, so you already know this. Rewrite the area in terms of 1 variable. That's very important. And then, given the quadratics, you have to find the vertex somehow. You know the formula, you can use the factored form, you can use the standard form. It doesn't matter which form you use, you need to know the tool that you already have learned about in other videos. and state the final answer. This is sort of the mapping that you're creating. And now the actual application. So we need to solve the problem now by doing the following. So in this particular questions, L and W will be utilized for identifying the length and the width of that rectangular shape. So let L be the length, let W be the width. Please do not strictly think that this is the only letter that I must use. Pick your own letters because you're learning for yourself. So once we have L and W, the perimeter is 2L plus 2W. In the context of the word problems, I know that the perimeter is 40 because this is the fencing amount. Remember, 40 meters around. So 2 lengths and 2 widths is 40. Every time you have an equation, before you do anything, it is always a good strategy to make it simpler. Simplifying by dividing, in this case, each term by 2, both sides of the equation. So this is why you see L plus W is equal 20. So it's much easier to work with simpler equations. So if that makes sense, adopt this strategy. Always make it simpler before you start rearranging. So now we have 2 variables. So we can express this equation in many different forms. We can express in terms of L, in terms of W. Say we're going to solve it for W as a new expression. So W now is 20 minus L as the width, and L is the length. So now we can create one expression for the area with one variable, and this is how we do this. So the area, we do understand, is a product. Length times width. L is a different variable, W is a different variable. So the goal here always is to create one. So we do the substitution. We know from the previous page that W is equal to 20 minus L. So you're going to use L here, and 20 minus L you substitute here, so that the area product becomes a product with one variable. So now you're making connection here. One variable for area function. So the notation here is 8a is a function of L. So that's why you see it in brackets. So this is similar to the function notation. So please note, this is not the product when we do letter F times letter X. We don't do letter A times letter L. It's just a notation. So that may be familiar to you. If you were to use letter X, you would see X times 20 minus X instead of L times 20 minus L. So I'm just telling you that letter choice, it doesn't matter as long as you understand the process. So you have the area function in terms of one variable so that you can start working with that. So this is a quadratic function because we have a product. 2 variables multiplied, identical variables multiplied together. So this is like second degree term. So we are in the right spot. Now you're making connection. You can think of quadratic formula for the vertex in that standard form, or you can use the factored form. Your goal is to find the vertex, right? Because now the area formula is a quadratic function. I have to optimize from this point. I have to find a vertex. So that is the best length value. Once I have the length, I can find the width. So I did optimize the shape, dimensions of that rectangular field. So right here, instead of for me and you doing the long way, expanding it, creating sort of standard equation, I rather skip that. I would utilize what I already have to save time. So make it equal to 0 to find roots of that equation. And those are the x-intercepts, if you remember factored form of quadratic equation. So when you find those two x-intercepts, you divide them by 2 by adding the total, divide by 2. So you're finding the average. So this is the location of the x coordinates of the vertex of quadratic function. You probably remember this from other videos. If not, please go back and watch so that it will make sense. The second method you could do, expand it, create that equation right here, and use the formula for the vertex. It doesn't matter which method. So don't cling to a single method. You eventually develop a strategy that works for you the best. And I'm pretty sure that this strategy is very easy because we already have factored form, find roots, find the average, and boom, you have the location of the vertex. So this is the right step or right location to be at, because you already know that the vertex does exist and where the vertex can be found. So 10 represents the length dimension. How long is one side of the rectangular shape? Boom. Once you have the L, you can find the W, because length plus W is equal to 20, right? So you find the W using this equation from the previous page. Boom, you have all the dimensions that you wanted to find. This question may have extra step, and sometimes it does. They say, okay, now we have the dimensions. What is the best area? So knowing that the area is the product of length times width, you know how much is length, how much is width. So boom, you have the area value, which would be the extra questions added in case there were questions like that on your test, on your quiz. So hopefully this video now makes sense. Now you became an expert of how to optimize the area, a rectangular area, given the dimension where the perimeter is fixed. So as usual, we learn through practice. Implementation is the key. Mastery of learning occurs when you start implementing your knowledge immediately. Thanks for watching. Don't forget to share it with your friends. See you next time. Bye for now.